Right, there shouldn't be any real surprises on the um on our little link here. We start the draw. Okay, so looking at the main body, there's no names, so call them what you want. We have the 15, and we have the 20 for the thicknesses, with an overall then of 60. Let's see, the length, pretty straightforward. If this was all the same length, same thickness, I would look at doing the thin feature or an offset. But since it's not, we'll uh, probably not use that as an example, or I'll do it as an example later on. This view is looking in the direction back over here. And our pins are different sizes, so even though we could do the configurations, the little square on the end makes it a little more difficult. And we're only talking about 4 parts, so that should be pretty straightforward. So I'm going to go ahead and pause. Okay, so let's go ahead and get our part started, and we'll do the C clamp, or the C shape. So let's fly that out of the way. We'll start our metric part. And we'll go with the front plane and a sketch. And if I do L on the keyboard, then it doesn't really matter where we start. I want to stay with their dimension scheme though, so probably we'll drag that out a little closer to 60. And then across the top we have 40, and we can do that on the top or the bottom, doesn't really matter. And then that one is 20, 20, and didn't take that one for whatever reason, so let's go ahead and fill those in, and we'll try again. Okay, and since it didn't quite line up, I'm going to go ahead and connect the dots and then just go back and tell it that it's horizontal. Alright, so selection is if I think that these are always going to be the same, then we'll start off with collinear, and then I'll make them equal. And that way we have the 20. Let's see, the distance in between. We go ahead and fly that in, see if we can find it. That may be a missing dimension, in which case we have a thickness of 10. So we need a little bit of clearance, and then that one's an M10, so probably wouldn't put over a millimeter of clearance, but if that's going to be 16 with a 12, that's like 2 millimeters on each, on the radial. That's a lot of room to move around. And I'm not seeing that thickness, so you get to decide. Probably would expect something like 12, but I'm going to go with 11. So let's pick the shape. And since there isn't one, I'm going to do an overall then. So if we go 50, that'll put it at 10. And that would be kind of a standard number. I think probably too close. So let's go with the 51. Okay. And then in our tolerance, let's see, 25.4 for the to an inch. And then that would put us real close to 2 inches anyway. All right, and then the depth, we have 15 millimeters from the back on the side, And that'll get us started for now. So a right click and extrude. And I think previously when I've done this project, I've made it mid-plane. So if we do mid-plane, we can take advantage of that being on center. It doesn't really matter. So let's see, we have 15. Is there a 30 somewhere? So again, looks like a missing dimension. So let's just go with the 30. All right, and we'll start with the M10 on the back, and since they're not giving us a pitch, I'm going to go S key, and that was a cut extrude, not the. So we'll try that again. Pre-select, S key, hole wizard. There we go. They look kind of the same. And we'll let that come up. We're in ANSI metric. Going to thread. Let's go ahead and reset. I usually reset the custom sizing. Don't really remember what I did last time. So M10 by 1.0 is fairly fine. 1.25 is in between, so probably more common, and the 1.5 is a fairly coarse. So custom sizing through all, not really going to hurt anything. Positions. All right, and then we'll make sure that we're in the point tool. And this one is going to be centered. So I could put it on the middle. So they have 30. Oh, there it was. There was the 60 overall. So it was 20, 20, and 20. So somewhere in here, as we go through the iterations, we find it. There was the 60 on this side and 30 to the middle. So that's a lot of clearance for that piece, but gives us the opportunity to use the width mate. All right, so that being the case, if I were to go with the line L, make sure I'm in the work area for construction, and I can say that I always want this to be centered. If I go midpoint to midpoint with that line, then look for the midpoint to place the hole wizard item, and we get that in position. All right, so if I double click on the boss, double click on the 51, change it to 60, we're going to see that open up. And then we need to rebuild. All right, so after we've gone through that, so this might be a place if you want to do the 14 millimeter through the top as a hole wizard or as the cut extrude, that would be okay. The M12 on the bottom would be okay. I want to try this. Always open to an experiment. So let's use the advanced hole. We'll make this a single feature. And so we have that one selected. This is going to be just a through hole. And we'll pick it up from the ANSI metric. It's going to be a standard drill size. We'll be going down quite a ways to find the 14. Okay, so 14. And the end condition will be up to selection, so we can pick that inside face. On the back side then, we'll pick the far side, or what would be the bottom of the part. On the far side then, that shows it going all the way through, and we can do a straight tap. And it's going to be not an M1.2, that was our M12. And staying kind of in the middle, the M12 by 1.5 is not the coarse, not the fine. And then up to next element is okay. And the thread class showing as 1B. Now if it's going to actually use that, we're going to call it out as a 2B. And let's see what that gives us. So going from the top, we need to place it. We can go, oh, I right-clicked. So just like in the whole wizard, right-clicking with that little checkbox kicks you out. So I'm just going to edit the sketch. We'll go S key, center line, midpoint to midpoint to establish our center location. And typically, unless there's a real good reason to offset it, these are going to stay on center. All right, and then the pushback is 13. And we accept it. And okay, so if this was 2 whole wizard features, that would be fine. What I'm not seeing in here is the cosmetic thread. So one of 2 things could be happening. The whole thread is there. And if we go to the hidden lines visible, we see the hidden line for the whole and not seeing it on this one. So interesting that, let's check that real quick and let it get back in. So on the thread, we'll see if there's a checkbox. And the whole callout, it has the class, but it does not show the cosmetic thread. All right, so callouts definitions is going to show up in the drawing, but it did not pull the cosmetic thread, so we'll just go ahead and accept that. All right, so we're going to use the cosmetic threads a couple times. This is our new topic. So if I do a selection on that edge, insert, and all the way down a little bit further to annotations and cosmetic thread. Cosmetic thread is what's going to give us those lines, that simplified thread form. And this is going to be ANSI metric. And we're going to be at M12 by 1.5, hopefully. There we go. It's right in front of me. We'll go ahead and do the thread class again as 2B. And I really don't want it to show the type in the drawing. If it does the thread call out as that, that's going to be fine. And usually this is more of an H value with our taps or with our callouts. So now we have the lines, and we have the all of our geometry for the C bracket. All right, so we're going to save this. We're going to need to establish our file documentation trail. So finding my location, my assignments, I'm going to create a new folder, assignment 4. And this is going to be the C bracket. Okay, so we can go back into solid. We can leave it. Let's go ahead and pick up our next part, and we'll do the link, kind of the odd round, and the choice with the odd brown. Let's go with the top plane because that's what I want as far as where it's going to go into the assembly. And on our choices for the odd brown, we have the straight slot or the center point slot. So if it's going into material, it's a slot. If it's producing material, it's an odd brown. All right, so the center is 55. And then we bring it out, and now it's staying pretty consistent. So 24 on the width. Yep, the odd brown, even though we put in those inputs, it did not keep them, but if I enter them, then that numeric input, they should come out at least on location. So 55, and then We'll wait for it to catch up there. Okay. And then I want to go into sketch entities, or we could do S key in the circle. And we'll draw the two circles, and that has a radius of 12. And I believe they are both 12. Nope, one of them is 16. That's right, we said that was going to be fairly loose on the shaft in the orientation that they have it. And then the features will extrude, and it will go to 10 millimeters. And we'll save it. Make sure it checked. There we go. Save. Returns to my folder, and this can be the link. Save. All right, so the pins, the 10 millimeter, I'm going to go ahead and close these since my computer is lagging a little bit. And the part metric. So the pins, if we want to stay with the orientation for the one on the left, I would put it. I would put this in the right plane and go that way. And then when I bring it into the assembly, it's already there. And this one from the top, it doesn't really matter if we do them from the front. We're going to be able to maneuver them around in the assembly. So let's just stay with that as an example. And S key circle, so an M10, and we said so the major diameter is going to be 10 millimeters, and we're going to extrude that out to a total of 42. And that looks a little better. And just on orientation, I want it to go the other way. There is a 2 millimeter chamfer on the leading edge. I thought maybe there was a radius on the backside. That looks kind of sharp. I'd put a radius or a chamfer on the backside too. Alright, so we'll go in, pick up the chamfer, and on the chamfer tool, we're going to go 2 millimeters by 45 degrees. And on our choices up here, we have the angle and the distance and distance, and then the other lengths. So I'm not seeing a preview, so let's go ahead and check it. And tangent propagation. Really, does not like that. Well, let's make sure that my number is correct, and that's 10 millimeter diameter. Chamfer. Now that would still leave 6 millimeters on. There we go, got the preview that time, so I don't know if it just hung on the 10 millimeters, which it certainly cannot do. All right, and then picking that leading edge, insert, annotation, and this is one if I was doing a lot of these, I would probably add it to the heads up or add it to the S key, and we'll do some customizing here with these guys. So the M10 by 1.25 I believe is what I put in there since I'm picking the middles. And it is not going to be through, it is going to go 15 millimeters, so blind in condition, 15 millimeters. And we look at it from the side, that looks pretty good. And we'll go and M10 pin. And if I wanted to, I could go ahead and adjust this. I have not had a good reason to use the sketch plane. Said I wanted to put the M12 pin in the other orientation. So before I mess this up, let's do a save as. because I will overwrite the existing if I'm not paying attention. Save as copy and open. And we'll rename this to M12 pin. Save. All right, so this is a little trick that comes in handy occasionally if you're not too far in the sketch. And we can go ahead and close the original document. If you're not too far into the sketch and the geometry is not too difficult, then you can edit the sketch plane. And we'll go from the right plane to the top plane and accept it. Now it did go the wrong way, which is not entirely out of the question. So if I edit it again and we go back to the right plane, that should bring it around. And well, you've got a 50-50 shot at it. And top plane, nope. Okay, so we're just going to edit it. Occasionally, I can walk it around those planes and have it generate the geometry the other way. So our overall on this is going to be 75 minus 15 because I want to add the square. And we'll look at another process. So 75 minus 15, I could type that in and get to 60. And we'll go ahead and accept. And then the chamfer stayed, and it goes to 3 millimeters. So if I can identify that, and we do a rebuild. All right, we'll try that again, rebuild. Okay, that looks better. The cosmetic thread, oh yeah, we need to adjust for our diameter. That goes to 12. And the cosmetic thread, we'll see, might not be too happy. We haven't rebuilt it yet, so let's go ahead and edit it. So just like the rest of our items, if we right click and edit the feature. All right, and then also don't be hesitant if this gets too crazy to no, it's gonna to recognize that it needs to go ahead and rebuild. So it updated. If this gets too crazy, don't hesitate to make this a separate part. Same process, extrude it out, put the chamfer on it, then we'll put the boss in. And so our M12 is now active by 1.5 and its length is 20 millimeters. Okay, and then we can accept it. And quick check is to go to the front view. Any of the perpendicular planes will show our geometry. Opening up a sketch on the end, we will right click S key, do the pull down center rectangle. And the rectangle is 9 squares, so if I do 9 enter and 9 enter, it will automatically add the equal relation. And this is where it gets a little interesting in that we have the corners to contend with. So typically you would make this on a lathe, do the threading, set this around, and then cut those corners. So choice is to extrude this out and then chop those off, or we could go ahead and do a convert entities. And then in our features, or right click and extrude, we need to pick. Okay, so that one's selected. It's going to be 15. We are merging the result. And then the contour will be the interior, and go ahead and accept it. The other option is if we had drawn this cylinder all the way out and I put that box on the end, then when I go to make the extrude cut, I don't think it's going to show up here. If I were to make an extrude cut, I would flip this side to cut so it remove those little items. So we'll do that later as an example. All right, so M12 pin. Oh yeah, we already have that one. There's my 4 parts. We're ready for the assembly and the drawing.